In this video, I want to solve another exercise of the questionnaire which is part of the 2011 math exam for a scientific school, also called Liceo Scientifico in Italian. I will translate this second problem for you and then we will solve it. The problem can be translated as find the point on the curve y equal to square root of x which is closest to the point of coordinates for 0. So it's quite a straightforward problem. We have the function y, sorry about this, we have the function y equal to the square root of x, which behaves more or less like this. So this is y equal to square root of x. This is the x-axis, this is the y-axis. And we want to find a point on the curve, somewhere here, for example, such that its distance from the point 4, 0 will be minimized. So we want to minimize the distance, this distance here, from this point to the curve. So we want to find a way to express the generic distance from this point to the curve. We want to describe it in terms of the x variable, and then we will minimize that function with respect to x, and we will find the minimum distance, which will be something like this, somewhere here. And we will call the function d of x, so the distance, which would be a function of x. And if we call the generic point x, y, and y will be equal to the square root of x on the curve, the distance will simply be equal to the square root of x minus 4 squared plus square root of x squared, like this. So this will be the square root of x minus 4 squared plus x. Now, we can also minimize the distance of x with respect to x squared. So if we square the distance, we find x minus 4 squared plus x. And if we minimize this function, which is squared, we will still get the, let's say, the answer to the problem, because the square of the function will still be minimum at the same point x, where the function itself will be minimum. So these two will have the same minima, right? And it's quite easy to understand that, because if you take the derivative with respect to x of this function dx squared, you can also rewrite it as 2 dx d of x derivative with respect to x of d of x. So if you exclude, of course, those points where d of x is 0 and d of x is not 0, you can see it easily that the distance will never be 0. So if you set this equal to 0, this will be 0 only when this derivative is 0. And therefore you can see that this condition corresponds to the condition that the derivative of the function itself should be 0. So you can easily understand that the point x, which minimizes our function, will be the same for both dx squared and d of x, right? So we can simply take the derivative of this, which will be simpler to calculate. And the derivative of that is twice x minus 4 plus 1 equal to 0. And this is a parabola, and the concavity of the parabola is like this. So it will have a minimum somewhere. So we already know that we will find the point which minimizes our function, d of x. So the point will be given by this equation. And this equation gives us 2x equal to 7. So the point x is located at x equal to 7 over 2, 3.5. So the point has the coordinates 7 over 2, and then we have to take also the square root of 7 over 2. So this is the point on the curve which minimizes the distance between this point for 0 and the point itself, which in this case is this one.